Hi viewers, welcome back again to HVAC Simplified, and today's topic of the day is HVAC air distribution system. So today we are going to see how a HVAC air distribution system is designed and some few characteristics of HVAC air distribution system. The fundamentals. Duct is simply a path to distribute and manage the airflow to the required design zones areas. Duct shape may be circular, square, rectangular or spiral. Galvanized iron, aluminum, stainless steel, black steel, iron, etc. are used for commonly used in the duct material. The thickness of the duct sheet is mentioned by its gauges. Aspect ratio is the ratio of the duct width to height. Aspect ratio 1 to 4 is generally advised for duct sizing. The sizes and shapes of the ducts will depend upon the CFM, available space for ducting, application, etc. Basically, CFM is known as cubic feet per minute, in which the airflow is actually measured. So, this is one of the parameters or a unit that airflow is measured. Airflow is also measured in different parameters like liter per second, meter cube per hour, etc. Direct connection to the equipment through flexible connectors. All the branches are fitted with VCD, volume control damper. Fire damper is provided to the equipment outlet and other duct penetrating firewalls areas. Thermal insulation is done for supply air duct. Acoustic insulation is also done for supply air duct. Here is the plan view of an airflow pattern. As you can see from the outlet, the primary air comes out and it is distributed into the room and the floor. Here is the sectional view of an air duct, and the airflow affects the walls and the ceiling and the throw from the duct to the room. HVAC duct drawing. This is one of the simple example of a HVAC duct drawing which is connected to the fan coil unit, the supply air duct and the return air duct. Some fundamentals. Air outlets are selected based on the manufacturer design data. Types and location of the air terminals will depend upon the room design and anesthetics. Louvers are fitted at the fresh air duct entry. Fittings and transitions are designed according to the SMACNA and ASHRAE standards. Flexible canvas connections should be used to connect the equipment and ducting system. Access should be provided for dampers. Air handling unit should be provided with drain and U-traps. Gasket to be used between duct joints to prevent leakage. Never run the air handling unit unless the air handling unit room is clean and filters are mounted. Now let us see the different types of ducts terminologies and their uses. The first is the supply air duct, return air duct, fresh air duct and exhaust air duct. Duct designing methods. Basically, the duct design sizing is done on three criteria: velocity reduction method, equal friction method, and static regain method. These are the three different methods through which duct design can be done. Now let's look at the velocity reduction method. Velocity, which is measured in FPM, feet per minute, which is equal to volume by area. Main duct velocities should be considered between 1200 to 1500 FPM. Branch duct velocity should be considered from 750 FPM to 900 FPM. Collars, drops velocity should be considered between 300 to 500 FPM. Plenum boxes should be considered 500 FPM. Return air duct velocity shall be less than the supply air duct velocity. Equal friction method. Consider the total ducting will bear the same friction losses. For example, 0.08 inches of water per 100 feet of 1 water per 100 feet. This is typical example where we need to consider the ducting will bear the same friction loss throughout the sizes. The range will differ depending upon the application and the uses of the space. These are the different classes of airs and their static pressure limits, maximum air velocities, and permissible air leakages. Any duct in HVAC system is classified into low pressure class A, medium pressure class B, and high pressure class C. So depending on the classes and the applications, different pressure limits are obtained depending on SMAGNA and ASHRAE standards, where the maximum pressure drop and the maximum air velocity is defined. Duct classification as per SMAGNA. In inches of water gauge and in Pascal and their operating pressures is defined here. So for example, if the static pressure is 125 Pascal, which is half inch of water gauge, not exceeding half inches of water gauge should be the operating pressure. Duct seal classes. More than 2 inch to up to 3 inch of water gauge, which is 750 Pascal. All transfer joints and longitudinal joint seams. The class C up to 2 inch of water gauge, which is 500 Pascal, is transfer joints only. Seal class A, application static pressure class more than 3 inch, which is 750 Pascal, all transfer joints, longitudinal seams and duct walls penetrations. Airflow management. Duct designing and construction consideration. The duct should be considered the available space for the ducting. Ducts should be tested for leakage. Transitions and fitting pressure losses should be considered for blower design. 20% maximum area reduction is allowed in ducting in case of obstructions. Factors to be considered: airflow, throw, noise level, appearance, and space restrictions. Distribution system plans and symbols. Here you are going to see the positive pressure supply, the negative pressure, return or exhaust. These designs are considered in duct designing to identify the types of ducts. This design for the square illustrates the supply air duct, and the negative pressure return or exhaust is drawn in this particular way. Air terminal designs, airflow indications and directions. This is a typical example of a supply air diffuser or the supply air duct, and this is an example of a return or an exhaust air duct. Flow pattern. The diffusers are classified into basically 4 patterns, which is known as one-way, two-way, three-way and four-way, which simply indicates the flow of air in the directions. One-way diffuser was only directed through one way, and by the name itself, two-way, three-way and four ways are the directions of the air terminals flow pattern. AHU fan designing. The CFM to be delivered is obtained from the heat load calculation. The fan static will depend upon the pressure loss through duct and duct fittings, the pressure loss at damper, the pressure loss at flexible duct, the pressure loss at terminals, and internal fan losses. Fan selection. Calculating the pressure drop. Identify the path having the maximum pressure. Calculate the pressure drop in the selected part ducting and duct fittings. Calculate the pressure drop in the part dampers and other accessories. Calculate the pressure drop at the terminals and internal losses and sum of the calculations. Thank you very much guys. Hope to see you soon.